Okay, today is we're going to talk about the spinal nerves, the branch of the peripheral nervous system. For those of you that are watching on YouTube, this will be good for you to do this. Is Monday, you missed class, and you missed all the fun stuff that we're doing here. So anyway, here we go. Spinal nerves. There are 31 pairs of nerves that come off the vertebrae. Now these come off the sides of the vertebrae. Between the bodies, there is a space there that has intervertebral disc, right? And behind that are two little openings, one on each side, that call the intervertebral foramen. And coming out of there are spinal nerves. Those spinal nerves take the information from the spinal cord to the periphery of the body. Or they pick up the information from the periphery of the body and take it through that little opening into the spinal column itself. So we have 8 cervical spinal nerves. Now wait a minute, how many cervical vertebrae do we have? 7. So how do we get 8 cervicals out of that? There's one on the bottom between C7 and T1. That's the difference. So that gives us the 8th one. 12 thoracic, 5 lumbar, 5 sacral. Remember those little holes on each side that people say, what goes through those holes? Those are spinal nerves that come out of there. And then we have 1 coccygeal, which is kind of different too, right? How many coccyx do we have? 3 to 5 coccyx, right? But we only have 1 nerve that comes off that area. And there's no real little openings from that. It's just that from the location is what that one turns out to be. So this is the way that they come out of the spinal cord. Now we have little enlargements that we find in the spinal cord because of the amount of nerves that come out of that area. How much innervation is taken out of that area is due to the arms and the legs. So the enlargements are due to these arms and legs additions. We need more nerves that go to your fingers and your hands and things like this, so we have more nerve fibers that are coming off there. And we get more integration coming through that way for reflexes and different aspects that way. So we have the cervical enlargement and we have the lumbar enlargement. Those 2 areas. We find those specifically in those areas. Now remember that the lumbars, the spinal cord only goes down to L1, right about that area there. Then from here on down it's called the cauda equina, horse's tail. It's still nerves that are coming down through there, but they're not condensed into a spinal cord per se. At the bottom of the spinal cord we have that conus medullaris. It kind of comes down to a point. And then the nerves come from there. And this down here is the sciatic nerve that comes off and goes down the back of the leg, and it's accumulation of nerves, different nerve levels of that spinal cord. So it's not just one nerve, it's multiple nerves that come off that area. Each spinal nerve connects to the spinal cord via 2 roots, the ventral roots and the dorsal roots. The ventral roots contain motor fibers, or we call those efferent fibers. These go to skeletal muscles. Skeletal muscles. So the ventral root, skeletal muscles. Dorsal root contains sensory afferent fibers, and these conduct information to the spinal cord. And they all come out through the intervertebral foramen. Little picture of how that all kind of looks. Here we have the spinal cord itself coming off, where we have the little wings here, and then we have the ventral and the dorsal roots. The dorsal roots is in the back of the spinal cord, and the ventral roots, of course, come off the front of the spinal cord. And it even goes even further than that. When the dorsal ramus comes off, it goes back to the back muscles. So we have different branches that come off. And then we also have a communication system that goes between the nerves. So we have the nerves come out of the spinal cord and goes into these little ganglia here, and then it can either go to this ventral ramus or to the dorsal ramus, to the different parts of the body, and then it can go up and down the spinal cord, spinal column, in these little areas. Okay, so we have gray matter, white matter in the spinal cord, but we have the nerves that are coming off that area, going in and out of the spinal column itself. So coming off these spinal nerves, we have rami, or branches. Rami is just a branch of these nerves. So it comes out of the intervertebral foramen. Once it gets out of there, it has a ganglia, a big mass of cell bodies, and from there it branches either to the ventral rami or the dorsal rami. Dorsal rami goes to the back muscles. The ventral rami goes to the front of the body, the muscles in the front of the body. Rami communicans are automatic pathways that join the ventral and the rami with the thoracic region, so information can go up and down the spinal cord. So when we look at this, here's the spinal cord here. Right here is the spinal cord, and then it comes out through the intervertebral foramen, which is right there. Then it branches. The dorsal rami goes to the back muscles here, and the ventral rami comes around and goes to the front of the body. Your rectus abdominis, your transverse abdominis muscles, those types of things, pectoralis muscles, all are innervated by that ventral rami, a ventral branch of the spinal cord. Now, in the neck we have what we call a plexus. A plexus is a convolution of nerves. Our body is set up very beautifully in that if we cut one nerve, for instance, one nerve gets damaged, there are other nerves that can accomplish or go around that area in a kind of a communication network and keep everything still viable. So instead of one nerve going down to your shoulder, innervating, making your whole arm work, we have several nerves that do this. If one becomes damaged, the other ones can still make that arm move a little bit. Now, you're going to lose some function, but you're going to still maintain some function in that area. So the cervical plexus is formed from the rami of C1 through C4, the anterior branch of C1 through C4. This is what Christopher Reeves came into problem with. One of the most important ones in this area, C1 through C4, is the phrenic nerve, which comes off the C3 through C5 area. This one goes to the diaphragm. If you damage these areas, C3, C4 area, then you can't, your diaphragm doesn't move, and they have to put you on a respirator. So Christopher Reeves was a good example of how that works. Now in these plexuses, the cervical plexus, as you can see in this diagram, these nerves come off, the rami come off the spinal cord here, different areas, but look at how they communicate. They're all intertwined. The communication system, the nerves are mixed up. It's like a network or a cobweb of nerves. If you cut one area, the information can still go around another area. See? So if we cut right here, and we damage it, information can come this way and still make it down the arm. That's what the plexus is all about. Some of these plexuses will connect with some of the cranial nerves, like the accessory nerve. But the phrenic nerve is a really important little nerve in that cervical plexus. Brachial plexus is a little bit lower, and it's the one that comes off for the arms to work better. So this forms from the ventral rami from C5 through T8 and L1, or T1, excuse me, and it gives rise to the upper limb. Now, we break this plexus into roots, trunks, divisions, and cords. Okay? I really don't care if you remember all the different cords and the roots and things like that. That's more than what we need to do for this class. Just suffice it to say that these nerves come off and they course down the arm in different places. What's a funny bone? What's the funny bone? Is it a bone? It's a nerve, right? So that's one of these branches of these brachial plexus. It comes off and it forms those. So the roots are from the 5 ventral rami. The trunks, we have the upper, middle, and lower trunk. We have the anterior and posterior divisions of these. And then we have the cords, which are medial, lateral, and posterior. Let me see if we have a diagram of how that works. Here's how they come off. Here's our C4, 5, 6, 7, 8, and T1 come off through that, and when they come through, they are creating branches. They are communicating together, sending information from one nerve to another nerve. As it courses down, they also branch in, they bifurcate here and branch out. So we have information coming up and going out of these nerves. These are sensory and motor. Yes?
What does plexus mean?
A plexus is kind of like a multiplex theater, mini type of thing. I guess that's trying to relate it to something that's common, but that's kind of what it would be like. A place with many theaters in it. Well, this is an area with many nerves going to it. So that's the best way I can describe a plexus. Convolution, communication area, spider web mechanism, but they're all kind of manipulate together. Now at the end of this plexus, we end up with the radial, median, and ulnar nerves, and also the musculocutaneous nerve. These are the main ones that come down into the arm. These nerves here, they're the ones that go all the way down into the fingers and in the hands. The rest of these are kind of small branches that go into the armpit, through the axillary, but most of these go all the way to the bottom. They innervate different things, like the musculocutaneous goes to the bicep, and then we have the radialis and brachialis. These are all innervated by different nerves, and they're all on your little chart there that you can look up if you want to. I'm not going to get specific on those. So this is just a little different type of a chart where it tells you the nerve here, where it comes off the spinal cord, and then we break that into trunks. Then the trunks are broken down into divisions, and then we break the divisions down into cords, and then they go back into cingulary nerves. And each one of those nerves innervates a different muscle of the body. They are taking care of the skeletal muscles. It's just a different type of a flow chart. But you can see that they're not all the same. They're not just one nerve that comes out. C5 doesn't go to just the fingers. But what the beauty of this is, we can look at our nervous system and say, okay, I can't feel anything in my thumb and my little finger. I can trace that back because of this, back to the cervical area. And it can tell me what part of the cervical area is in trouble or where there is a problem in that cervical area. Yes?
Just a quick question. Like, if you have like surgery and things like that, you know how they impact your tissue and obviously you have a ton of nerve aids there. Now, for a while after surgery, you're not going to have a lot of feeling in that area. Do you ever get any of that back? I mean, once the nerves have been severed like that or cut through?
It depends on how big a nerve and how much damage has been done. But a lot of times, no. And especially on a big surgery, you're going to have a dead spot on that area. Now, if you cut your finger or something like that, it could take a long time. I know one time I was working on a fence, peeling some plastic off a plastic fence, and I sliced my thumb really deep. I never went to the doctor. I just, thought, well, it'll go away. It was numb for probably 3 years. I couldn't feel hardly anything in there, but it eventually came back. A lot of that is the body just kind of goes around that area and forms nerve regeneration a little bit, but it takes on kind of a collateral area. It makes everything kind of respond that way. It's like in the brain, if you have a stroke, initially you lose function in that area, but the body has this ability to go around that damaged area and still connect up those nerves from the kind of the back way. It comes in from the back. Same way with the blood vessels. If you get a blood vessel that's plugged, the body will try to send blood from another collateral circulation into that area to keep it alive. So we have that ability to a certain degree, but if you damage it a lot, it's not going to come back. The closer you get to the spinal cord, the bigger the nerves, the more you cut those, the less you're going to get back. The ones in your finger are very, very tiny. They're basically just minute little things. But if you cut it way up here in the arm, it's not going to come back very good. Because you have to remember, these nerves are not just one nerve. They're a multiplex of these nerves, a bunch of different nerves all running in the same nerve itself. So we have nerve fibers, and upon nerve fiber, and you cut the whole thing, you've caused a lot of damage.
So like with surgeries and stuff too, they do nerve blocks.
Mm-hmm.
Do they send something in a nerve to like, I guess I don't understand how those work either.
They just basically short the nerve out so it doesn't send impulses to the brain. So they'll send in like a special chemical in there that numbs that area or stops that action potential from happening. And then if there's no impulses going to the brain, you can't feel it. Your receptors are still going wild, and wherever you're getting cut, they're screaming, ouch, 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 but your brain isn't getting that message. So sometimes when people don't get deep enough in anesthesia, they're under, but it's kind of, they haven't hit that area where they've numbed it completely. They're still screaming inside, they just can't get it out. They feel it. It's not a good thing. So yeah, if you, the bigger the nerve that you cut, the more damage you have and it won't come back. So, very good questions. So the brachial plexus comes off. We have these main nerves that come off the brachial plexus. Axillary goes to the armpit. Musculocutaneous goes to the biceps brachii and brachialis. Median nerve innervates the skin, some of the forearm and the hand. The ulnar supplies the carpal ulnaris and the flexor digitorum profundus. And then the radial goes through and innervates the medial extensor muscles and the skin of the limb. So when we look at these, the ulnar nerve is the one that's going to give us that funny bone reaction. It's going to make us jump all over the place. Just a little diagram of how they course them through. Here's the ulnar nerve that comes down underneath, right underneath that area of the body, where we're going to, right here is where we're going to have our funny bone hit, and that's the ulnar nerve that goes through there. Lumbar plexus is lower. This is L1 through L4. Now the spinal cord stops at L1. Where does the spinal cord stop at? L1, right? Good. All right, so it innervates the thigh, the front of the thigh, the abdominal wall, the bottom of the abdominal area, and the psoas muscle. Psoas muscle is responsible for, helps you cross your legs. Right? It kicks out the femoral nerve and the obturator nerve. Now, wouldn't you think that the obturator nerve would go through the obturator foramen? It does. That makes sense, right? That makes it easy. And the femoral nerve doesn't go through the femoral bone, though, the femur. It just kind of hangs along the anterior thigh and the medial surface of the leg. So if someone has L1 through L4, it's going to stay pretty much in the thigh area. So if your back is out, the upper back is out, that's where you're going to feel it. Now if we go deeper into the rest of the leg, we go into the sacral plexus. This is where we really have some problems. A lot of people have more problems in this area than in any other lower part of the back. L4 through S4. L4 through S4 is part of the sciatic nerve. The sciatic nerve gives you lots of pain. It can take months to heal. It's a nasty situation. Very, very big nerve that runs down the back of your leg. The thickest, the longest nerve in the body. Just think about Shaq's nerve. It runs from his lower back all the way down to his big toe. That's a long nerve. You know, his hips probably taller than I am, right? So, amazing. It goes to the hamstrings, the adductor magnus, and most of the muscles of the leg and the foot. Now, it kind of breaks down eventually into the tibial and the common fibular nerve at the bottom of the foot. And that's kind of where we get that crossing over. But as we look at this, all these nerves kind of come together to form this big nerve down here. So most of it, even from L4, if you can trace it, it goes right down through this area. And then this L5 comes down and goes through here. But we also have segments of all the other ones that come in together with that. It ends up with two nerves that come off the bottom, basically. And then we have the posterior femoral that goes to the back of the leg. And then we have the pudendal nerve that goes down in the pubic area. Comes back, swings back around in the pubic area. Same way with the coccyx, it feeds the pubic area. But the sciatic goes all the way down the back of the leg, clear to the big foot, clear to your big toe. As it courses down the back of the leg, it does bifurcate at the bottom. It goes the fibularis and the tibial. And across the back of the knee, it's a popliteal. And so it just kind of, it's named after the areas of the body that it goes through. That's the sciatic nerve. Really important one. Now, this is one of the things that you're going to need to know. Of course, I keep saying that, right? But I'm sorry, but this is something you really do need to know. When you do your assessments in your classes, in the hospitals, and wherever you're going to work, if you're going to be especially if you're going to be a nurse, these are the things that you're going to know. Dermatomes. These are called dermatomes. These are areas of the body, areas of the skin innervated by a cutaneous branch of a single spinal nerve. Okay, so we can, if there's a problem on the skin of the body, we can trace that problem back to the spinal cord. And we'll look at that. All spinal nerves except C1 participate in dermatomes. So we can trace it back. So if we have a problem in the arm, part of the arm is numb, you can't feel anything. If we know our dermatomes, we can trace it back to that area of the spinal cord and we can see if there's a problem there. Is it out of place? Is the nerve bad? Is there a muscle pinching on it? Is there some type of damage to that nerve? What's going on with it? So we get some numbness, and sometimes it's not completely numbness. It's just a little bit diminished in sensation. So if I take someone and I go across their arm like this, and one side of the arm, the outside of the arm feels good. I can feel that really well, but when I go across, it's just like, it kind of feels like dead skin. I can still feel it, but I can't feel it really well. I can't feel it the same as on both sides of the arm. Right? Or if I stroke down the side of the stomach, on one side and not on the other side, one side's different. That can make a difference on your dermatomes. This is what the dermatomes look like. When you get into school, they're going to have you remember these. Each one of these areas goes to a certain part of the body, of the skin of the body. So let's say we have a problem with L5, S1, right at the base of our vertebrae. Okay, this is the most common area for a herniated disc, a problem, or a bulging disc, right? This is the most area that we're going to have problems with. Let's look at where that comes off. So we look at these areas. Here's L5 here, there's a little area, and you really can't see it, but this goes all the way down the side of the leg here. You're going to have numbness or some altered sensation down the outside of that leg. So if we say, okay, we run a pinwheel or a pin across, or just even rub a finger across those areas, you're going to notice that one area is very heightened, normal, and then the other one is going to be a diminished sensation in that skin. And that's going to bring you back to L5. So they're going to say, okay, I don't feel anything on that side. And that's where the dermatome for L5 is. You trace it back to L5 and you request an x-ray for L5. It's not definitive, but it kind of gives you a hint or an idea where things are going to be at. Now let's look at the fingers here. Here's C8. Here in the little finger, goes all the way up to C8. So on the outside, if your little finger is numb, you can't feel your little finger, that means that the lower, between C8, C7 and T1, something's wrong with that nerve coming off there, somewhere along the line. I get people in my office all the time and say, I can't feel my fingers. I have two fingers, I can't feel them on the outside. Well, I just trace that back to the neck, adjust the neck, and they go, how's it feel? Well, it's starting to feel better now, I can feel it. It just opens it right up. The nerve impulses come right down into that area. So we use it a lot as far as chiropractic, and medical doctors do also, as far as diagnosis and investigation purposes. Hilton Law, it says that any nerves serving a muscle that produces a movement of that joint also innervates the joint and the skin over that joint. So if the nerve goes to that joint, it's going to take care of the muscles over that area and the joint itself. Okay, so that's just Hilton's Law. It has nothing to do with Hilton, what was her name? They always got in trouble, you know, or motels. Right? Different guy. Now, motor control, we have different ways of doing this from the brain. We have segmental, projectional, and pre-command levels of motor control. Segmental levels are the lowest level of motor hierarchy. This controls locomotion, specific and repeated motor activity. Okay, so not a lot of thought processes goes into this. We learn this thing early, these movements early on, and we just go from there. Projection consists of upper motor neurons that direct voluntary muscle movements. Okay, upper motor neurons are inside the brain area. Okay, upper motor neurons. These are areas that send information to the muscles themselves. Projection motor pathways keep higher command levels informed of what's happening. So we get this information from the body. Okay, where am I at in space? Am I sitting? Am I standing? Am I laying down? The brain is constantly getting this information. We can mix it up too. Put you on a chair and spin you, it really messes the brain up because it doesn't know where you're at in time and space. You're still spinning. The brain is still spinning according to what its output is, or input. Now, pre-command levels are these neurons in the cerebellum and the basal nuclear area. These coordinate movements of posture. Start and stop movements. Okay, if you didn't have this area, when you go to pick up a glass of water, you just go right through it. You wouldn't be able to stop, grasp, and drink. These are the pre-command. Monitors muscle tone. How much should I grab that? How strong should I squeeze that glass? That's what it comes out. Okay? Preformed, unconscious planning and discharge of movements. Okay, that's all very good. Let's talk about reflexes. Right? Reflexes are cool. Right? We did some of those the other day. We hit each other with hammers, and we made the muscles contract, right? They didn't jerk, they didn't jump, they contracted, right? So reflexes are important. When we're young, we have really good reflexes. As we get older, our reflexes diminish. When we're kids, we're babies, we have a lot more reflexes than we ever have, right? We lose those. And I've got a chart coming up here with all the reflexes for babies. But a reflex is an inborn reflex, a rapid, involuntary, predictable motor response to a stimulus. If I tap right below your knee, your quads are going to contract, your leg is going to come up, it's going to move, it's going to extend, and that's the reflex. Why do we have reflexes? Well, the reason we have reflexes is to keep us out of trouble. If you put your hand on a stove, you just don't think, oh, look, my hand's on the stove. I better take it off. You don't do that. It's automatic. It becomes a faster reflex, faster response than it can get to the brain. When I put my hand on the stove, the information goes up my arm to my spinal cord, crossed by an integration or an association nerve, through that interneuron, and it comes back through the motor area and causes my arm to come off that. Before it even gets to my brain, it says, ouch. My brain doesn't even get a chance to say, hey, move your arm, dummy. It's hot. It's already done. That's a reflex. It's a protective mechanism for us. Remember Home Alone? When Marv comes through the window, right? I'm coming in. Right? What's he do? The ornaments, right? Steps on the ornaments. What does his feet do? You ever watch it? I guess I'm kind of weird because I looked at these things. But he steps on them, and then one foot comes up, the other foot goes up. He goes like he's dancing, right? Why? You ever think about that? Right. Exactly. So your one foot comes up, but then your other foot goes down on the glass, so it comes back up. So you end up dancing up and down. It's reflexes. Boom, 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 boom. Your brain can't even say, hey, wait a minute, stop. you're just making it worse. It's just your body keeps flipping it back and forth. Reflexes are awesome. They're fast. They're quick. You don't even know it. By the time you feel that pain in your brain, you're already moving. You're already reacting to that stimulus. And that's what keeps us out of trouble. Okay, so reflex arc. There are 5 things in a reflex arc. Know those 5 things. Okay? You have to have a receptor, sensory receptor. We have to have a sensory neuron. We have to have an integration center or an interneuron inside the spinal cord. We have a motor neuron, and then we have an effector or a muscle or a gland. 5 things. Receptor, sensory, neuron, integration, motor, and then we have the effector. Those are the 5 things that make up a reflex arc. And this is the way they work. If I stick a pin in on your little arm or wherever, the information goes down this nerve, this sensory nerve. Here's the receptor right there. Stimulates that to send an impulse down this sensory neuron. Comes into the spinal cord. It goes across this interneuron here. Sends information here. And then it comes back out to the hand or to the bicep to tell you to move your finger. Now we're also sending information across over to here that sends an information to the other hand that says, okay, slap this person that is putting that pressure on my hand. And at the same time, we're sending information up to the brain, and once it gets there, it says, oh, you creep, and that's when you get this slap, right? So information is flowing all over the place. But the fastest one is this nice little loop here, back to the muscle to make you move away from that. Your reaction after that is secondary. It comes in secondary to it. Spinal reflexes. These are within the spine itself, and basically we've talked a little bit about that. Somatic reflexes are important clinically so that we can determine whether someone is having problems or not. That's why we do reflexes on both sides. We do the Achilles reflexes, we do the patellar reflex on both sides to measure that one side is not more reactive than the other. If one side goes boom, really flares up, really contracts hard, and the other one goes boop, what does that tell us?